I'm here for my condition of firefighter. I'm working in the Fire and Rescue Service of Catalunya, and I will introduce a little bit the results that we get from the research that we are doing together with the University of UPC and together with my organizations. Okay, I will not talk about models. I feel more comfortable talking about real experience. Yes, this is what I do the day by day. So I start with this picture because it's a prescribed burning and something that is very common in our day by day. And this is in the Pyrenees last winter. And I want to highlight a couple of aspects. The first one is the transdisciplinary character of our research. We mix firefighters with researchers in order to see other ways to understand what is going on. Yeah, this was a prescribed burning, but the other thing I want to highlight is the fact that 1 month ago, just in that place, there was a wildfire that we extinguished as we usually do the day by day also. And the question is that if we can take advantage of this kind of situations from another perspective, the classical perspective. Okay. This is another example of a wildfire that we have last 2014 in Tivissa in the south of the country. And it's quite different because this is a convective fire, what we call a convective fire, with a behavior that is more difficult to control for us. And here we decide our strategic and tactical way to proceed here was for a matter of having a safer situation, we decide to confine the wildfire below 1,000 hectares. And when we decide that, the fire was about 300 hectares. Doing that, we achieved to save the first potential we identified that was about 5,000 hectares. But the interesting thing here is not the confinement strategy. The interesting thing here is that when we did the reanalysis, we realized about what happened in a broader scale. Doing that kind of tactics, we realized that we prepare a more resilient and diverse forest at a broader scale, at about 20,000 hectares. So we are smelling literally the possibilities, the opportunities that we have if we look at the fire with other eyes, yeah, as opportunity. So how to implement this change of paradigm from defense, that is what we did the last 40 years, is a big challenge. But we are smelling this. We know the tools, we know the tactics, but strategically and socially, it's a big change. So I'll go ahead with some of the contents that we have today. I want to give you a quick and simple point of view from energetics, okay, and extinction paradox. At the top line, we have items related with modeling, fire analysis and modeling, and we could say that at the bottom line we have process and elements more close to fire ecology and modeling also. What I will say is a very simple reason, yeah, but it's to explain the concept of hysteresis. So by the process of photosynthesis, kinetic energy transforms to potential energy in the form of biomass. Yes. So on the other hand, we have processes like fire that transform potential energy and dissipates to kinetical energy. So post-fire landscapes has the legacy of the pre-fire environments, and with unique self-organized properties. And what we are seeing here is the fact that they are interconnected process operating or performing at different scales of time and space. Yeah, and this is what hysteresis means. This is what we call in the field the memory of the landscapes. Yeah, different process interconnected at different scales of time and space. So this is quite complex. Yeah, from this point of view. Another thing to highlight is the fact that to understand the extinction paradox from an energetics point of view, it's a kind of impeachment in the potential energy of the landscapes. So to study what all the topics related with self-organization in landscapes, we have to understand the emergence phenomena, hysteresis, criticality, percolation, and all that. But to study that, we need to find some indicators, and what we tried to find and investigate was specifically this: the possibility to find heavy-tailed distributions in our data source. So the hypotheses were: is there any statistical signature for characterizing fire regimes, or could we capture the structural mechanism promoting the emergence of aggregate patterns? Or is there criticality and vulnerability of socio-ecological systems? So it's a complex systems approach. Yeah? Okay, we start with this data source. Okay, the official database of Catalonia. We take the last 30 years and also the shape of homogeneous fire regime zones. We treat the data in different with a GIS. And also, the interesting thing here maybe is that we did sub-series of time in order to try to understand and identify difference in time, yeah, in these patterns. So this is the methods, very fast. We first apply a test of plausibility for the existence of power laws in our empirical data. We also want to compare it with other possibilities or alternative of heavy-tailed distributions, so we apply a second test, and after a Gini index and Robin Hood index in order to prepare what we have done later, the statistical modeling. So, but in fact, we would like to go further and understand what there is beyond the power laws or this heavy-tailed distribution. So we start with a agent-based modeling approach to try to understand the structural mechanisms that they are beyond or under these heavy-tailed distributions. This is the phase of the environment of our model. I will not enter to this, we don't have time, but the interesting thing I think to point out is the fact that we add some extension at the classical fire percolation models, and basically is the fact that we enter to study and quantify the vulnerability in the wild-neural interface. We add this extension, and also we add some results in order to have an easier comparison with empirical data. So this is the kind of results that we get. This is the distribution, a logarithmical distribution of the frequency area distribution of our data source. And this is the results that we get with 150 sets analyzed. So we have practices more than 400 tests. And in all sets, we find this kind of data, test 1 and 2. And sometimes in all them almost we find truncated power laws or power loads directly. This kind of results for different set of data. For example, this is the first part of the period that we analyze, the first 10 years. We see at the last part of the period where we can see a truncation, and the other one is the first part of the period, and it fits with a power law in 3-4 orders of magnitude. more with single years and different sets. So I just want to stop here because I'm aware that I'm running out. The time is running out. So, but I want to spend 1 minute here. This is another kind of results that we get. These are the 5 years non-accumulated periods and the frequency area distribution from every of these 5 years periods. So the first thing we see here is that the total burned area of the last period has decreased in the tail. So the first period we analyze, we see larger fires, and this is the first thing. The other thing to point out is a collateral effect that we have identified, and is the fact that the sooner is the truncation in the power law, the higher is the activity density in the medium size. So this has connotations from the extinction paradox point of view, in the sense that not only largest wildfires are the ones that make us vulnerable, that now we have in the short time we already are vulnerable because there is an impeachment in the potential energy. So this is one of the important things that we have found. Yeah? And also it has connotations in terms of ecology, because the landscapes that comes after this kind of perturbations are more adapted to this higher intensity in the medium-sized class. Test 3, this is just very quick. This has annual burned area with the Gini index, and just say that there is no correlation between them, but the first period is the consequence of 40 or 50 years of land abandonment. And at the last part of the period, what we find is precisely the impeachment, the energetic impeachment, and that has the consequence that we already presented in the previous slide. So these are the discussions about our results. Integrate the methodology of Klaus et al. Has been very useful to reduce the uncertainty between different reference and visions. We find 3-4 orders of magnitudes considering 5-hour fire size boundary of plausibility for truncated power laws. And the other is that the sooner is the truncation in the power law, the higher is the activity density in the medium size. This is a new collateral effect of the suppression of suppressing systematically all the fires. So the last one, could wildfire generation concept be the mechanism promoting these statistical patterns? So the model is done. We are in that way, but we haven't finished it yet. To conclude, very fast, just say that we have 2 feedbacks. Yeah, the scientific one is quite clear. Says we can talk about criticality in fire percolation. We are aware of the landscape memory or the hysteresis impeachment, and also the new wildfire scenarios due to the inertia linked to P8 impeachment, so emergence of new situations. You should integrate that in fire regimes. But the question is not only what, is how. Yeah? So we have the opportunity to work side by side with natural systems inertia, that's why I put at the beginning the example of the prescribed burning, or because if we work side by side with the inertia of the natural systems, we can move the regimes into conditions that promote resilience in socio-ecological systems. And to explore how to do that change of paradigm, we start in parallel the analysis of emergency manager organizations from a complex systems point of view to synthesize novel capacities in our organizations. And this is where we are. Thank you very much for your attention, and it's on.